many times we may not be interested. We may not be interested in the particular points of occurrence. Particular points of occurrence. For example, if you look at, there are so many molecule particles, etc. And you are not interested in which molecule is going to this side, 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 etc. You are not at all interested. You are interested in the percentage or the proportion of molecules moving to right, moving to left, moving to up, moving towards down. Similarly, suppose you are buying a packet of items containing 100 items. Packet of 100 items. You are not at all interested whether the first item is good, second item is good, third item is good, fourth item is good. You are not at all interested. You are interested only in the number of good items. Number of good items. You are interested only in number of good items. Okay, whether all the 100 items are good or 99 items are good or 98 items are good or etc. Is it clear? Here, for example, I shall take a small example. Suppose you take 4 items. 4 items. Then all the 4 may be good. Okay. Then first 3 may be good and the last one may be bad. First 2 may be good, third may be bad, last may be good. First one good, second one bad, third and fourth good. First one bad, all the other 3 goods. Okay, in all these 3 cases, you are getting 3 good items and 1 bad item. Similarly, you can consider GGBB, GBGB, BBGG, etc. In all these cases, you are getting 2 good items and 2 bad items. Okay, that means what? We are interested in an aggregate of outcomes. An aggregate of outcomes. Is it clear or not? Okay, again.
Yes, sir.
Yeah. Suppose you consider, I shall do some small examples only. You consider families of 2 children. Families of 2 children. The elder one may be a boy, the younger one may be a boy. Elder one may be a boy, younger one may be a girl. Elder one may be a girl, younger one may be a boy. And both are girls. These are the 4 possibilities. A sociology researcher. That sociology researcher is interested in a number of boys in a family. Number of boys in a family. Okay, here you look, here if you look at these things, only symbols are there, B, 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 G, G, B, G, B. Only symbols are there. And we are not comfortable with the symbols. We are very happy with the numbers. We are very happy with the numbers. Okay, X is a number of boys in a family means X can take values 0, 1, 2. Therefore, this is our sample space. This is our sample space. This consists of BB. This consists of GB and BG. And this consists of GG. GG. Therefore, if you look at the number of boys in a family, then BB is corresponding to 2. X can take the value 2 or X takes the value 2 when the outcome is BB. When the outcome is GB or BG, then number of boys is 1. When it is GG, number of boys is equal to 0. Number of boys is equal to 0. Therefore, x can take three values 0, 1, 2. Then what is the chance that x is equal to 0? That's a question. X can take the value 0 when there are two girl children in that family. Probability of GG. How many points are here? 4 points are here. All are equally likely. Therefore, probability of x is equal to x is 1 by 4. Out of 4 cases, only one is favorable for x is equal to 0. Then probability of x is equal to 1. Number of boys 1. If GB is there, number of boys 1. If BG is there, number of boys 1. Therefore, out of 4, 2 cases are favorable. Out of 4, only one case is favorable for 2 x is equal to 2, the 1 by 4. For all other things, what is the probability of x is equal to 0.5? It is not possible. What is the probability of x is equal to 6? It is not possible because you are considering only families with 2 children. Therefore, for all other cases, the probability is 0. What is the total probability? 1 by 4, 2 by 4, 1 by 4, 1. That is, total probability of 1 is distributed to various values of x. This is called probability distribution of x. Probability distribution of x. Probability distribution of x. The total probability 1 is distributed to various values of the random variable x. And remember that if the total is not coming to 1, some errors are there. Some errors happen in some place. You have to check at this one. Now I give you an assignment. At least you define 5 experiments. 5 experiments, and you define some random variable on those experiments. Okay? Then you find the probability distribution. You need one more example or not? Tell me, please.
Okay, sir. This is enough, sir.
Yes, very good. Very good. Now, when x can take only finite number of values, x can take only finite number of values, you can divide 1 to finite number of points. Suppose x can take a countable number of values. Countable number of values. Then it is not at all possible to divide 1 like this. In that case, we have to use certain convergent series. Certain convergent series. For example, you know, e raised to lambda is equal to 1 plus lambda by factorial 1 plus lambda square by factorial 2 plus lambda cube by factorial 3 plus etc. This is expansion for e raised to lambda. You multiply e raised to multiply by e raised to minus lambda. Then this side is 1. Then e raised to minus lambda plus e raised to minus lambda into lambda by factorial 1 plus e raised to minus lambda lambda square by factorial 2 plus e raised to minus lambda lambda cube by factorial 3 plus etc. to infinity. To infinity. Now, if you take lambda greater than 0, e raised to minus lambda is always positive. Therefore, this is positive. Lambda is greater than 0. Therefore, this is positive, this is positive, this is positive, etc. Therefore, probability of E greater than or equal to 0 is satisfied. The total probability is 1. That is also satisfied. Therefore, all these can be considered as probability of certain events. Certain events. Okay. This you can take as probability that x is equal to 0. The second one you can take as probability of x is equal to 1. The third one you can take as probability of x is equal to 2, etc. This is known as Poisson distribution. Poisson distribution. Poisson distribution. I will give you one more example. Okay, you consider 1 minus q raised to minus 1. Okay, when q is less than 1. Now this is 1 plus q square plus q cube plus etc. Okay, let us take a 1 minus q as p. For our convenience, let us take a 1 minus q as p. Therefore, 1 minus q raised to minus 1 is p raised to minus 1. P raised to minus 1. You multiply both sides by p. Therefore, p into p raised to minus 1 is 1. 1 is equal to p plus pq plus pq square plus pq cube plus etc. Okay, here we have taken as 0 less than q less than 1. Therefore, definitely p is also 0 less than p less than 1. And 1 minus q is p. Therefore, p plus q is equal to 1. Therefore, this is positive, this is positive, this is positive, this is positive, etc. Now you can see that this is a geometric series with the first term p and a common ratio q. P, pq, pq square, etc. Okay, now you can take this as a probability distribution. Probability that x is equal to 0 is p, probability of x is equal to 1 is pq plus etc. This is known as geometric distribution. Geometric distribution. What's the practical application? Because this is geometric series. Suppose you are conducting an experiment. You are conducting an experiment and you will stop the experiment when you will get a success. When you will get a success. That's the type of the experiment you are doing. When you get a success, you stop the experiment. Okay? Now, you define a variable x, number of trials required. Number of trials required to get the first success. If you are lucky, you can get the success in the first trial itself. If you are lucky, you may get success in the second trial, success in the third trial, success in the fourth trial, etc. Success in the first trial means what? This is a sample point. Success in the second trial means what? First one failure, second one success. Success, first success in the third trial. Therefore, these are the corresponding sample points. Therefore, this one is what? P. Probability of x is equal to 1. Probability of x is equal to 1 is probability of getting success. Let us take that number as P. Okay, probability of x is equal to 2. Then you take probability of Fs. Probability of Fs is probability of F into probability of S, that is Q into P. Q into P is same as P into Q. Therefore, this is the practical situation where this distribution is coming into realization. Okay. Similarly, there are a number of distributions out there. Geometric distribution. Another one is binomial distribution. That also important. That also important. Suppose you conduct an experiment n times. N times. N times. Okay, in chemical reactions or whatever may be. And you define x. X is the number of successes. Number of successes. Okay, let's probability of the success is P. There are only two possibilities. Probability of success is P. Therefore, probability of failure will be 1 minus P. We have seen total probability is 1. Okay. You are conducting the experiment for n times and x is a number of successes. Then what are the different values for x? No success can be there, 1 success can be there, 2 success can be there, 3 success can be there, r successes can be there, and all the n can be successes. And what is your interest? I want to know what is probability of x is equal to 0. I want to know what is probability of x is equal to 1. I want to know what is probability of X is equal to R, etc. Okay, what is probability of X is equal to R? You are doing the experiment for n times and you want to know what is the probability that you are getting R successes. That means what? Probability of R successes and n minus R failures. N minus R failures. And what is one possibility? One possibility is success, 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 etc. R times and failure, 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 etc. failure n minus R times. This is only one of the how many possibilities? NCR possibilities. NCR possibility. There is success and failures can come in combinations, okay, in mixture. Therefore, you for each one and for each combination you will have R successes and n minus R failures. Therefore, out of n successes, sorry, out of n trials, R successes can be obtained in NCR ways. Okay, and success, 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 etc. R times, then the probability is P raised to R. Failure, 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 etc. n minus R times. Therefore, the probability is Q raised to n minus R. Therefore, this is the probability of getting R successes in n trials. R successes in n trials. Okay, then what is that one? If you look at Q plus P the whole raised to n, Q plus P the whole raised to n, then it is Q raised to n, NC1, Q raised to n minus 1 into P plus etc. NCR, Q raised to n minus R into P raised to R plus etc. P raised to n. This is a binomial expansion of Q plus P the whole raised to n. Now you look at this term. This is the R plus first term in the expansion of Q plus P the whole raised to n. Therefore, this is our probability of getting R successes and n minus R failures. N minus R failures. This is known as binomial distribution. What's the reason for the binomial? Name binomial? Because it is the R plus first term. It is the R plus first term. Probability of getting R successes is the R plus first term in the expansion of Q plus P the whole raised to n. Okay. Similarly, negative binomial distribution is there, hypergeometric distribution is there, uniform distribution is there. So many distributions are there. And with this background, you can study about all other distributions. Now, next point. Here we have seen that x takes the value 0, 1, 2, 3, 4, 5, etc. Suppose x can take all the values in an interval. All the values in an interval. Whatever may be the size of the interval, whatever may be the size of the interval, infinitely many points are there. Infinitely many points are there. Okay, that is the beauty of mathematics. That is the beauty of mathematics. Okay, and you know, if you take interval 0, 1, and if you take minus infinity, infinity, you can find a mapping from 0, 1 to minus infinity, infinity. Okay, whatever may be. That means what? We cannot take points 1 by 1 by 1 by 1 by 1, 1, 1, 1, etc. And we cannot assign the probability. Point number 1. That is impossible, practically impossible. Even if you take 0 to 0.0001, etc., you cannot assign probabilities by taking points 1 by 1 individually. In that case, necessity is the mother of creation. We have to make use of some functions. We have to make use of some functions. Can we take arbitrary functions? No. We cannot take arbitrary functions because these functions are leading to probabilities. These functions are leading to probabilities. Therefore, functions should be greater than or equal to 0. Functions should be greater than or equal to 0. And The total probability should be 1. Therefore, the total area should be 1. Total area should be 1. Any function satisfying these two conditions are called probability density function. Probability density function. The physics students are very familiar with this function, e raised to minus x square by 2. X is between minus infinity, less than x, less than infinity. You can add one more constant, 1 by root 2 pi. Okay, they are called a Gaussian law of errors. Okay, there are some named functions. Okay, I will discuss only 4 or 5 named functions, and I will stop that discussion. Okay, if you take f of x is equal to 1 by b minus a. For a less than x, less than b, you can take this is a, this is b. Therefore, 1 by b minus a is here. For all the points between a and b, f of x is same. It's a constant function. Therefore, it is called a uniform distribution. Uniform distribution. Because uniform, everything at every point, the value of the function is same. Uniform for the school students. If you take a particular school, the students have same uniform. Okay, uniform, everywhere the same. Okay, the next one is exponential distribution. Lambda into e raised to minus lambda x, x greater than 0, lambda greater than 0. It is called an exponential distribution. Exponential distribution. You can easily see that integral 0 to infinity lambda into e raised to minus lambda x dx is equal to lambda into e raised to minus lambda x by minus lambda between 0 and infinity. This and this you can cancel. E raised to minus infinity is 0. Minus of minus plus. Therefore, e raised to 0 is 1. The next one is gamma distribution. That is m raised to p by gamma p, x raised to p minus 1, e raised to minus mx, 0 less than x less than infinity. Okay, this is known as gamma distribution. Here again, you can easily verify that the total integral is 1. Next one is normal distribution. 1 by sigma root 2 pi e raised to minus x minus mu the whole square by 2 sigma square minus infinity less than x less than infinity. This is also known as Gaussian distribution. Gaussian. Okay. Gaussian distribution. Gauss, you know, name of a mathematician. Okay. Similarly, a beta distribution is there. Beta distribution, f of x is a 1 by beta mn x raised to m minus 1 into 1 minus x raised to n minus 1, 0 less than x less than 1, etc. Cauchy distribution, f of x is 1 by pi into 1 by 1 plus x square minus infinity less than x less than infinity. Okay, so many distributions are there. Okay, you can easily download some articles. And you can say that on your website. I remember one article, Kant's Handbook of Probability Distributions. Handbook of Probability Distributions. Handbook. So many books are there. Okay, handbook on statistical distributions. Yeah, for experimentalists, you can download it. You please spend 1 week on this. Okay, those who are doing research. Okay, and understand when you can use it to discuss so many things. probability density functions, Bernoulli distribution, beta distribution. You see, it is given in the alphabetical order. Binomial distribution, binormal distribution, Cauchy A, B, C now, chi-square, compound Poisson, D now, B, D, E now, error function. This is your normal. E, E, F, G, G, H, I no, J no, then L comes, I, J, K, L, M, N, there is no O, P, Poisson distribution, we have seen that. If you want one, you click on this one. Yeah. E raised to minus mu, mu raised to r by r factorial. It is giving moments, it is giving relations, it is giving probability function, it is giving cumulative distribution, it is giving addition theorem, derivation. Don't worry about those things. Histogram, random number generation, okay, and this one, okay. You can download it and you read the techniques. And one more book is there. One more book is there. My memory is very poor nowadays. Gallery of distributions that gives applications where you can apply. Okay. For example, double exponential. Click on that. It will go to that one. Double exponential distribution. Okay. It gives so many things, mean, median, mode. Okay, this is not the paper. I forgot. Yeah. It is buy one. You need not buy, so many things are there. So many free books are there. You please search and get with the applications. Oh, that is to purchase. You need not buy it. Probability distributions and distributions are fundamental concept. Yeah, this we have seen. What is probability distribution, locations, gallery, tables. Okay. Exploratory data analysis techniques, so many things are there. You can download 1 or 2 articles and spend some time on that. I'm sure that those who are working with theoretical physics, etc., this won't be a waste. Okay. Then comes, I am stopping the discussion of that one. Then comes some parameters. The first one is the expectation of a random variable. This we have discussed before, and I have stopped that discussion at that time because I thought that it is better to discuss it. Okay, suppose there are 100 students in your class. And chance that a student is getting UGC before completing the course is 0.3. This is a probability that a student is getting UGC CSR test is 0.3. Then how many students are expected to get UGC CSIR before completing the course? 100 students are studying in your class, and the chance that a student is getting UGC CSR is 0.3. What is the probability that, what is the expected number of students who get UGC CSIR? Please tell me, one of the students can tell me. Hello?
Yes, sir. Yes, sir.
All the students can. No, let the students answer, please.
Dinesh,
Anybody can ask. Can Matthews answer that question? 100 students are there. The chance that a student qualifies the UGC CSR test is 0.3. Then out of 100 students, how many students are expected to qualify the UGC CSR test? Nobody is answering. Then I am asking, yeah, very wonderful, wonderful. 100 into 0.3, that is all. This is expectation, finished. This is finished. It is as simple as this. Therefore, if X is the number of students expected to qualify, number of students who qualify. Then what are the possible values of X? It can be 0, it can be 1, it can be 2, and it can be 100. It can be 100. What are the only two possibilities? A student can pass the examination or fail the examination. Oh, this is called a point binomial distribution. Only two, binary distribution. It has got wonderful applications in communication theory. Because tick tock, okay? That is a signals. They are sending in the form of zeros and ones. And the combination of zeros and ones are used to represent A, B, C, etc. Okay, Boolean algebra. Boolean algebra, binary, arithmetic, all those things are same. Okay, wonderful applications. Therefore, here what is X? X is the number of students who qualify the examination. Out of 100 students, how many are qualified? Then 0, 1, 2, 3, etc. 100. Then what is the expected number? On an average, how many students qualify the examination? That you got 100 into 0.3. It is called the expected value of the random variable X, expectation of X. Now let us write a formula. If X1, X2, etc., Xn are the values of the random variable, and P1, P2, etc., Pn are the corresponding probabilities. What is P1? Probability that X is equal to X1. Probability of X is equal to X2. Probability of X is equal to Xn. Then expectation of X is defined as X1 into P1 plus X2 into P2 plus etc. Xn into Pn. Now it is a mathematical problem. You simplify it. That's all. Algebra, simple algebra. Okay. For example, if X takes a value 0, 1, 2, 3 with the probabilities 0.4, 0.3, 0.2 and 0.1. The total should be 1. That is important. Okay. Then what is expectation of X? Expectation of X is value into probability plus value into probability plus value into probability plus value into probability. That is 0.3 plus 0.4 plus 0.3. Okay, that is 0.3 plus 0.4, 0.7 plus 0.3, 1. That is in the long run, understand the word. In the long run, X will be very close to 1. That's all. When the experiment is conducting again and again and again and again, then X will be on an average, X will be 1. That's all. Expected value. It is a limiting case. Okay. Similarly, you can define the moments. Expectation of X raised to R. This is called the rth moment. Expectation of X raised to R is what? X1 raised to R into P1. That's all. X2 raised to R into P2. Plus etc. xn raised to r into pn. Some moments are very important. Okay, variance of x is defined as expectation of x square minus expectation of x the whole square. You please take a +2 mathematics book. Okay, these variances, standard deviation, expectation, etc., all are defined and a number of problems are done in +1, +2 mathematics book. Okay, and the standard deviation is square root of variance of x. Square root of variance of x. Okay, now another important point is distribution function. Distribution function. It is very important. Suppose x takes the value 0, 1, 2, 3 with the probabilities 0.2, 0.3, 0.4, 0.1. What is probability that x less than or equal to x? That is the question. Probability of x less than or equal to x. What is probability of x less than or equal to -1? It is 0. Because the first value itself is 0. Therefore, no values are there which are less than -1. Therefore, probability of x less than -0.5, that is also 0. Therefore, probability of x less than or equal to x is 0 when x is less than 0. Then, what is probability that x less than or equal to 0.5? There is only one value with a non-zero probability, that is 0. The probability of x less than or equal to 0.5 is probability of x is equal to 0. What is probability of x less than 0.9? That is also 0.2. Probability of x less than or equal to 0.9999999, etc. Therefore, for 0 less than or equal to x less than 1, it is 0.2. Now, what is probability of x less than or equal to 1.6? 1.6 is somewhere here. Below that, there are only two values assuming non-zero probabilities at 0 and at 1. Therefore, it is 0.5. 0.5 for 1 less than or equal to x less than 2. 0.9 for 2 less than or equal to x less than 3. It is 1 when x is greater than or equal to 3. Okay? What is probability of x less than or equal to 4? All the values 0, 1, 2, 3 are less than 4. Therefore, you have to add the corresponding probabilities. This is called the distribution function of the random variable f of x. F of x. Therefore, in any probability scenario, we are having 4 functions, namely 4 functions are there. One is probability function, and other is distribution function, other is quantile function, other is random number generation. What is the random number generation? Suppose you have to generate randomly some observations from normal distribution. We cannot take blindly 1, 2, 3, 4, etc. No, that is not random. That is not random. There was some mechanism should be there to generate random numbers. Okay, in R, all these things are available with a single click. To find probability function, D, and the name, some name tag. For distribution function, P, name tag. For quantile function, Q, name tag. For random number function, R, name tag. For example, D norm, that will give you probability for normal distribution. P norm, distribution function. Q norm, quantile function. R norm, random number generation. For binomial, D binom, P binom, Q binom, R binom. For Poisson, D Poise, P Poise, Q Poise, R poise. Like that. Okay. I have given a link R book. Okay. R book. Last day I have given you the link for the R book. MNOPQRST. Where is the R book? Yeah. R book. And you can control F, D, no. No. Oh, this is not that book. This is not that. It is R for beginners. Okay. The other book is the R book. Yeah. I have given the link to all. Location desktop. Oh, it is desktop. Is there? It is there. Okay. Okay. And you can control F, B, no. 114. Yeah. Next one. Is better I say random number generation. Random number generation. Yeah. Functions of the density cumulative theta, D poise, P poise, Q poise, R poise for Poisson. Okay. Yeah. For Poisson distribution, for multi-normal distribution, everything it is given. Everything it is given. Okay. Therefore, you have to remember these 4 letters and the codes also. Codes also. Okay. For example, suppose you have to generate 10,000 random numbers. What is to be done? R norm. Finished. R norm 10,000 numbers or 1 lakh numbers. No problem. What are the parameters for normal distribution? Mean and the standard deviation that you give. Then plots. Plots R norm. Or suppose you want to know hist R norm. Whatever may be. Whatever may be. Okay. Must be numeric. Okay. X is equal to this. Yeah. Where it is hiding somewhere. Yeah. Yeah. You are getting histogram. You can see normal curve. Normal curve. Normal curve. Now you can see symmetry. Okay. Suppose you do this one for n is equal to 100. This much symmetricity may not be available. That is, I shall change the color to make it different. Okay. This much symmetricity may not be available for small values of n. for small values of A. Why you are not helping me? The color should be given in the graph. The color should be given in the graph. Yeah, you can see. You just see the previous graph and this graph. Okay, now nowadays it is very easy. It will take only 1 or 2 seconds. I have increased 1000 to 100 to 1000. Now if you take 1000, yeah. If you take 1 lakh, no problem. It will not say I have headache, I will not do work. Yeah, you can see, and you can increase. Sometimes I don't know whether my computer has enough capacity. Yeah, it is working. It is working. All the values are between -4 and +4. Okay, suppose you want to frequency. History frequency is equal to false. You want the probabilities. Yeah, up to 0.3 only taking. Up to 0.3 only taking. Same thing you can do with all other things. Suppose you want to generate binomial. That's all. Bino. Suppose you are generating only 10 observations. 10 observations. There are 2 parameters, n and p. Suppose n is 20 and the probability of success is 0.6. 0.6. Okay, then you do this one. Yeah, this is for binomial. Now you increase the numbers. You see, it is going to symmetricity. It is going to symmetricity. Binomial tends normal. Binomial tends normal. See, you can now play your game. You change the probability. Suppose the probability is 0.9. Probability success is very high. Now you change. You can see number of successes will be more. Number of successes will be more. Why? Probability of success is very high. 14, 15, etc. Now this is a way to learn things. Suppose this probability is 0.2 only. Number of failures will be more. Number of failures will be more. Yeah. Number of successes less. Okay. Therefore, these are the 4 prefixes you have to remember. B for probability, P for cumulative distribution, Q for quantile function. What is quantile function? Q know. Okay. Q know. What is 0.5 0 1 0 1. Okay. Yeah, you are getting 0 because you know normal distribution is symmetric. Normal distribution is symmetric. Here mean is 0 and standard deviation is 1. Okay, therefore up to 0, the probability is 0.5. Therefore, this gives an inverse relation. What is the value of x? What is the value of x for which probability of x less than or equal to x is 0.5? That is the advantage of this Q function. Okay, you want to know the solution of this equation. Probability of x less than or equal to a. If this is 0.5, what is the value of a? What is the value of a? Other one is What is probability of x less than or equal to x? What is probability of x less than or equal to x? This is distribution function. This is quantile function. Okay, it is something like this. Distribution function will be like this. The graph will be like this. Here, if you are given this point, you have to come to this point. This is inverse point. Inverse point. Okay, you need not worry about too much theory about that. Too much theory about that. If you have some doubts, please ask me and make it clear. I think you are all familiar with these concepts. That is why I am just explaining the R codes. Tell me if you have some points to clarify or some doubts about that, you can ask me.
Sir?
Yeah.
Sir, you have written 3 values inside the bracket.
Which one?
Here, inside R norm.
Yeah.
Inside, then.
This is no. I will explain all those things in detail again. Don't worry.
Okay,
Don't
I'm
worry.
a little bit confused because.
Don't worry about that. Don't worry about that. I shall explain everything. Thank you for your question. Thank you for your question. Okay. You take binomial distribution. Binomial distribution. There are two parameters n and p. N is the number of trials and p is the probability of success. Why they are called parameters? To find the probabilities, you should know these two things. That is, probability of x is equal to 1. This is NC1, p raised to 1, 1 minus p raised to n minus 1. Therefore, if you don't know the values of n and p, you cannot find this. That is why they are called parameters. Probability of x is equal to 2, NC2, p raised to 2, 1 minus p raised to n minus 2, etc. You consider Poisson distribution. Only one parameter is there, lambda. E raised to minus lambda, lambda raised to x by x factorial is the probability of x is equal to x. For example, probability of x is equal to 5 is e raised to minus lambda, lambda raised to 5 by 5 factorial. For normal distribution, f of x is equal to 1 by sigma root of 2 pi e raised to minus x minus mu the whole square by 2 sigma square. Therefore, two parameters are there, mu and sigma. Mu and sigma. Mean and standard deviation. If we have no idea about the parameters, we cannot do anything. We cannot do anything. Therefore, you have to specify the parameters. You have to specify the parameters. For example, suppose you want to generate random numbers from normal distribution. Therefore, x is equal to R norm. R norm. R for random, norm for normal. Bracket. How many random numbers you want to generate? That you have to give first. That you have to give first. What is the value of mu? That you have to give next. What is the value of the standard deviation? That you have to give next. Then you draw the histogram. You draw the histogram. Now you can see the histogram. You can see the histogram. Yeah, you can see the middle value is 2. Normal distribution is symmetric about a mean 2. Mean 2. You keep this one in your mind. No, why should you keep in your mind? I can help you. I can help you. How can I help you? R, MF, ROW, C bracket 2, 2. I can draw 4 graphs. 4 graphs for you in a sheet. Okay? In a sheet, I can draw 4 graphs. It will sit in one corner. Yeah, it will sit in one corner. Here you can see middle value is 2. Then I am changing this 2 to 4. 2 to 4, you will get a different type of curve. Different type of curve. Middle value will be 4. Middle value will be 4. Middle value will be 4. Yeah, you can see 4 is the middle value. 4 is the middle value. 4 is the middle value. Here minus 5 to 5. Here it is coming 2. Then I am changing this to 10. And I have to give parameters. No. Wait. You can see middle value is 10. I can give the middle value as a minus 10. No harm. No harm. Mean can be negative also for normal distribution. Yeah. So you have to specify the values of the parameters. Then suppose you want to do Poisson distribution. R-Poise. 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 UIASC is the name of the function. There is only one parameter, lambda, and lambda should be positive. Therefore, Poise lambda you give. This is Poisson with the parameter 2. Now I am changing the parameter to 4. You will get another density with a different shape. You can see Poisson with the parameter 14. You can see symmetricity is coming. Poisson with the parameter 140. Binomial, 2 parameters are there, n and p. Suppose n is 30, probability of success is 0.5. You have to give n and p. You will get one type of curve that is sitting there. Okay, I am changing the color to gold so that it is not repeating. It's not repeating. Okay, you should get another curve, and I have not changed now. 30, I am changing the probability to 0.8. 0.8. It is for okay, and if you change the parameters, no, it is not R-Poise. Sorry. Now we are speaking about binom. Binom. Let me don't take this one. I have to delete this thing. For binomial, I have to do R binom. R binom. Okay. Parameters. This
So
one.
color hasn't come gold.
Yeah. It has not come. Error mistakes. R binom. Oh, this much is not acceptable. Okay, no problem. What is wrong with the gold?
Sir, that should be coming to the histogram.
Yeah, thank you very much. I have done the same mistake before. I am a double fold. Repeating the same mistake is, call it characteristics of a double fold. Okay. Because I'm in a hurry, that's a problem. You throw away this. Okay, you take the first one, okay? Then you change the probability to 0.5 and you change the parameters to 10. You can change the shape, okay? If the parameter is 20, another type, okay? And if the parameter is 200, it will be more symmetric. It will be more symmetric. Yeah. And for exponential distribution, there is only one parameter, lambda into e raised to minus lambda x. Therefore, you got to do REXP. REXP. Only one parameter is there. Therefore, you give lambda is 2. I am giving lambda is 2. You can see exponential distribution. And lambda is 4. And I am giving color green. I am giving color green. Okay. And lambda I am giving 1. And color blue. Blue. Yeah. And lambda is 10. Lambda is 10. What is the next color I know? Yellow. I know only 4 or 5 colors. Even I don't know which year. Okay. Yeah, like this. Now you are getting some idea about the order. The first number is the number of observations you want to generate. The first number is the number of observations you want to generate. And then you have to give the parameters. For binomial, 2 parameters are there. For Poisson, 2 parameters are, sorry, 1 parameter is there. Poisson. For exponential, 1 parameter is there. For gamma, 2 parameters are there, M and P, like that. Am I answered your question? Hello?
Yes, sir.
Your confusion over?
Yes, yes.
Okay, please tell me whether your friends have some doubts. Tell me. Actually, we take at least 1 month in a classroom to discuss up to this, starting from probability, then coming from finite probability, then countable probability, then density function, distribution function, Condell function, random number generation. At least 1 month we will take, 30 hours at least we will take in a classroom. And everything, you are lucky that, no, you are very lucky that you are not getting bored, okay? Hearing same thing for 30 hours means what? You may feel to commit suicide, okay? Boring, quite boring, no? Now everything we have put in a capsule form, and I have given wonderful reference books also, our book, or you can get so many things, you just type generation of random numbers using R. At least you will get 1 crore articles. How many are there? Where is that number? Flown away? Flown away? Where is that number? I cannot see that number now. Okay. Surely you will get more than 1 crore articles. Okay. You just take 1 or 2 articles. You just take 1 or 2 articles. Okay. Don't waste your time to download it, etc. Some universities are there. Sheffield universities, Stanford University, so many universities are there. You take the articles of those professors, generating data numbers, make me analyst, stats, UCLA, I think it is also ResearchGate. Where is using R? Stanford. Let us take some IIT IIT is Stanford University. IIT Kharagpur, they have wonderful articles with them. Okay. They are giving, setting a seed, etc. That I will explain tomorrow, making your own random generator. Okay, how to get these things. If you are not happy with that, why? Simulations in R, RPOIS, apply function. Okay. Yeah, you see different. These are using ggplot, I think. Yeah, ggplot. Wonderful. You just copy this one, paste it in your R discussion. Okay. Now you may need ggplot library ggplot2, I think, if I remember correct. Otherwise, no problem. It will show a error message. We can correct error message. Some error is there. Let me check what is that error. No, it is doing something. It is doing something. This is a way of learning. Okay, this is way of learning. No problem. Yeah, you can get same type of car. Wonderful car, no? With the different colors. Combined one. Legend. Somebody asked me last day. Legend. This is what legend. They have given labels, legends. Okay, you have to specify everything. You can see bin width, alpha value, position identity. So many things are there, and you are getting. This is the reaction with one chemical. This is a reaction with other chemical. This is a reaction with other chemical. This is the effect of one pressure. This is the effect of one pressure. This is the effect of one pressure. One velocity, another velocity, another velocity. You can make wonderful comparisons also. You can write at least one small paragraph on this graph. These are not beautiful. This one,
Yes.
this single line is doing that work. This single line is doing that work. But you have to call an expert. This you have to get from me for the first few days. Because I got it from my teachers. Okay. I have attended a number of workshops like this. Then they give me some idea. For plot, you have to go for this. For random number generation, you have to go for this. You go like that. Okay. Similarly, those things you can get from me in the beginning. And after, when you become an expert, you can jump without a ring. Okay. Now you jump through the ring. That's all. You see how many numbers it is generating in 1 second? 20 lakhs. 20 lakhs numbers it generated. Okay. Now, if there is a will, there is a way. That's all. You take all the, you sit for some time. You see multivariate clusters, Monte Carlo simulations, everything is available in, I don't know who is this professor. Question 14, actually it is an assignment given to his students. In this lab, we will learn how to simulate data with R using random. Yeah, okay. That professor was giving an assignment to his students, and after the assignment, he has given the answers also. Okay. If you are not happy with this, you take something else. That's all. Something else. That's all. Stanford Computer Science. Okay. And the physics students, you can become wonderful data analysts. If you know a little bit of Python and a little bit of R, then if you want to make money, you can do that work. But I will not advise. Because within 10 years, you will have neck problem, you will have back problem, you have from this problem, etc. Because you have to sit in front of a computer for 15, 16, 17 hours a day. Okay. Health-wise, that is not a good job, but money-wise, that's a wonderful job. Okay. Any other question? Any other question? Hello?
No, sir.
Sir, actually,
Yeah.
hello.
Tell me.
Actually, what is the difference between plot and ggplot?
I think plot is in base module. Plot is in base module. He can give only paracetamol for you. Is it clear?
Yes.
Okay.
So this is more advanced.
Correct. If you want this type of beautification, that basic module cannot do that. If you want only this, you just do what I am doing this one. I am doing this one. The same thing I am going to do. Plot. Plot. Okay. Plot. Combined P1, etc. That itself will not work sometimes. Plot. Let me take another example. Let me take, empty cards. Let me take empty cards and head empty cards. Head empty cards. Head empty cards. What are the variables there? MPG and displacement. MPG and displacement. Okay. Plot MPG, comma displacement. I think I am correct in the spelling. Yeah, you can do so many things. I have to select only one. MPG with displacement. Okay. Empty cost dollar. Empty cost dollar MPG and empty cost dollar displacement. Yeah, only this paracetamol you can get. You can do some little color changes. You can put some headline, etc. only. Yes or no?
Yes, sir, clear, sir.
Yeah. If you want to get this one, where is that? If you want to make your presentations more beautiful, was it ggplot correct? I don't know.
ggplot too.
If you want this type of comparisons and more things, different colors, etc., then you have to go to a super specialty hospital. Okay, they may do some surgery and other things and make you like this. That's all. This is something we have plastic surgery now. Okay.
Okay.
Any other question? Surely you can do many things in base module, but that may not be, the output may not be in the way you wish. You will get output also, no problem. You will get output also, no problem. Here they are combining 3 processes. Please ask me whether you have some questions. Jolly Boss, sir, do you have any question?
No, sir. Actually, in that plot norm distribution, the parameters are not given. Only number is given. In that program, you have copied.
Where?
In that ggplot2,
Here.
pop 1 equal to r norm, then whether it is taking 0 as.
Yeah, that is, he is a wonderful person. R is a wonderful person. If the distribution is standard normal, you need not specify anything. if the distribution is standard normal, you need not specify any parameters. You just specify the number of observations you want. By default, it will take it as standard normal. Here you can see 1 and 2. Mu is 1 and standard deviation is 2. If it is something different, if mu is something different than 0 and standard deviation is something different than 1, then only you specify. If we are not giving anything, he will take it as standard normal distribution.
Okay, sir.
Yeah.
Thank you. Thank you, sir.
He's making our life very comfortable. Any other question? Any other question? Yesterday I told you that I will give you some assignments. I'm giving some assignments using ggplot. You can take your own questions and you make different plots with a different shape, okay, different colors, different headings, different labels for x-axis, y-axis, different types of legends, etc. Okay, because it is a task. It is a task. You might have seen that I'm skipping a number of graphs because I don't have that beauty concept. Okay, where should I put, what color should be the ideal one? You need not send me the answers. You just do yourself. Okay, because plots, diagrams, etc. are the difficult one in any presentation. Any other questions?